This video shows how to use Patran and MD Nastran to perform a basic finite element analysis. MD Nastran is one of MSC Software's enterprise simulation solutions. It is a finite element analysis technology originally developed for the NASA space program and is now considered the standard in the aerospace, automotive, and heavy machine industries. Patran is the leading pre- and post-processor for CAE simulation. For more information about MSC Software or MD Nastran, please go to MSC's website at www.mscsoftware.com. This slide illustrates the finite element analysis workflow between Patran and MD Nastran. Patran does the pre-processing or model creation where you import or create your geometry, create your finite element mesh, apply loads and boundary conditions, create material and element properties, and then submit your model to the solver, in this case MD Nastran, which solves for displacements and computes strains and stresses, before writing out a results file which is read back in to Patran. Then post-processing can occur where you create deformation plots, fringe plots, or reports. The basic process that we'll show for a finite element analysis is, first we'll create a new Patran database, then we'll import geometry using File, Import, Parasolid. We'll create a solid finite element mesh using this parasolid geometry. We'll then apply our loads and boundary conditions. We'll define material properties, and then apply those material properties to our elements with element properties. We'll then perform a linear static analysis using MD Nastran. We'll access our results via an XDB file, and then create a combined fringe and deformation plot using Patran. We now begin by opening Patran and creating a new database. Once the database is open, we'll define our model preferences. In this case, we'll enter an approximate maximum model dimension of 10 units and then have tolerances that are based on this value. We'll have an MD Nastran as our analysis code and structural as our analysis type. We're now ready to import our parasolid geometry. So we'll navigate to the directory that contains our strut.xmt parasolid file. We can see that one solid body was imported, and rotating our model, we can see our landing gear strut. We're now ready to create our finite element mesh. We'll set the action to create, the object to mesh, and the type to solid. We'll select our solid and enter a global edge length of 0.5 to determine the size of the elements. Click Apply, and we can see that our finite element mesh has been created. Next, we'll apply our loads and boundary conditions. First, we'll create a displacement condition. We'll give it a name and input data. We'll constrain the X, Y, and Z translation for this lower surface that we'll select here. So we'll select the lower cylindrical surface of our landing gear strut. Click Add, OK, and Apply. And we can see that translation in the X, Y, and Z direction will be constrained there. Next, we'll create a total load to apply force to our model. Again, we'll give it a name, in this case landing load, input data, and here we'll apply a load of negative 7,080 pounds in the Y direction. We can then select our application region, which will be this top face of the landing gear cup. Click Add, OK, and Apply, and the vector arrows show that a total load of 7,080 pounds is applied in the direction shown. Next, we'll create our material properties, where we'll create an isotropic material by manually inputting its data. We'll give it a name, in this case steel, an elastic modulus of 30 times 10 to the 6th, and a Poisson's ratio of 0.3. For this simple analysis, these are the only material properties necessary. The next step is to apply these material properties to the elements in our model. We'll do this by creating a 3D solid property set. We'll input our properties, and the only properties that need to be selected are the material. Click OK, and now we'll select where these material properties will be applied. We'll apply them to the entire solid, click Add, OK, and Apply. We are now ready to submit our model for analysis. From the Analysis menu, we'll Analyze, Entire Model, Full Run, and select MD Nastran and Linear Static as our solution type. Click OK and Apply, and Patran will submit the job to Nastran for analysis. Once the job is complete, we can access our results by attaching an XDB file. We select the strut.xdb, click OK, and Apply. Now that the results are back into Patran, We can view our results by creating a quick plot. We'll select our result case, and our fringe result, or color result, will show our von Mises stresses, and for our deformation, we'll show our model's displacements. Click Apply, and Patran will generate this plot for us to view our analysis results. We can see our maximum and minimum stresses, along with our maximum deformation. In this video, we've seen how simple it is to use Patran and MD Nastran to perform a basic finite element analysis.